student. Today we'll discuss on crystal structure. Crystal structure. Okay. Now, before to discuss that crystal structure, we have some knowledge. Actually, have to discuss on some basic definitions. Like, as we know that solid can be divided into material. Solid material can be divided into different types of, depending on the atomic arrangement. Depending on the atomic arrangement, the solid material can be basically crystalline solid, crystalline solid, crystalline solid, and non-crystalline solid. Or it's sometimes also called amorphous solid. Okay. Now, solid can be divided into, mainly depending on the atomic arrangement, the solid can be divided into two parts or two categories. Now, crystalline solid and non-crystalline solid. Now, crystalline solid material or the material that it follows a particular arrangement of atom in a repetitive manner. So, if suppose this is the atom, 1 atom, 2 atom, 3 atom, 4 atom, 5 atom, this atom arranged in such a way that it follows a particular arrangement. Okay, if it is happens so, then it is called crystalline solid. Okay, this is called crystalline solid. Some example of metallic crystal or crystalline solid are like that: copper, Ag, aluminium. Okay, and non-crystalline solid or non-crystalline material or solid amorphous type of materials is basically called where the particular arrangement are not maintained. So particular arranged in orderly manner, but they are basically randomly distributed. So atoms, if arranged in such a way that though no particular arrangement, they just follow like this. So the atomic arrangement is different from structure to structure. Okay, so this type of material called amorphous type of material or non-crystalline solid or amorphous type of solid. Okay, now obviously, and one more point, that they do not have directional properties. This is the important point, that they do not have directional properties. Okay, and wide range of melting point. Wide range of melting point. So example is that glass, rubber. So this type of material basically amorphous type of material. Okay, now we can discuss on some other type of material or some other type of definition, like unit cell. Okay, unit cell, basically the atoms or molecules are arranged in a particular fashion. Okay, so atoms and or molecules are arranged in a particular fashions, and these atoms or molecules are assumed to be continuous to extend to infinity to in all three axes in the same fashion. Okay, as the bricks are laid in massive masonry structure. And obviously that unit cell is the smallest part of crystal structure, smallest unit, as you can say, that is the smallest unit part. Okay, as it is called, is the smallest unit part. So obviously or you can say that this is a building block. It is called building block that can describe that can describe the crystal structure, okay. So different choices of unit cell can be possible. Suppose this is the material structure, so this is the atomic arrangement of crystal structure, okay. Suppose this is the crystal structure. Now suppose this is the repeated block, so this one, so this one, just you cut it out from this structure, it look like as it is cubic crystal unit cell, okay. So atoms are arranged, suppose the crystal are arranged in such a way that repetitive block in a manner that it is in cubic shape, then the unit cell it is called, it is a building block that can describe the crystal or structure. Also you can say the atoms or molecules are arranged in a particular fashion. So atom and molecule are arranged in a particular fashion, if it is repeated particular fashion throughout the crystal structure in a particular fashion, okay. And obviously these atoms and molecules, okay, assume to continue to extend to infinite in all the three axes, because it is a cell that can fill up the whole crystal structure, and this structure is maintained throughout the crystal. So that's why it is called unit cell. And as like its formation of bricks, okay, as the bricks are laid in a massive masonry structure, so all the bricks are constituted, or all the bricks are assumed to be a unit cell of a particular masonry structure. As like same in a crystal structure, the unit cell is the building block, as like bricks, okay, in a masonry structure. In case of masonry structure, bricks is your unit cell. It is, if you assume that, now if you assume that the material is the constitute a particular arrangement of atom, if atoms are arranged in a such way that it can form the throughout the crystal structure, then this type of unit cell that is repeated in a manner that can form a particular crystal structure, so this is called unit cell, or it will sometimes also called a building block structure, okay. This is called unit cell. Now if you can go to the next topic, that is lattice parameter of unit cell. Lattice parameter of unit cell. Lattice parameter of unit cell. So atoms are basically in 3D mode. So as we see that the atoms are basically cubic in structure. So if you draw the atoms in a particular plane like XYZ plane, okay, XYZ plane, and the angle like alpha, that will be beta, and that will be gamma. The actually length of this structure, if it is A, this is B, this is C. As you see that in the diagram, lattice parameter of a unit cell. So there are some parameters that can define a unit cell. So that is basically it is from actually that's intercept, that is ABC, okay. Suppose this is the XYZ axis in which the unit cell is intercept at a particular point in x direction, that is A here, that is Y direction is B here, and this is the C direction, so, okay, in the Z direction actually, that is C here. Now the three angles can be alpha, beta, and gamma, okay. That can be, it's also called interfacial angle, alpha and beta and gamma, that is called facial angle, okay, interfacial angle. So these are the lattice parameter, the length that can intercept and the angle in which the atoms are arranged in a particular x, y, and z plane, that is alpha, beta, and gamma, and a, b, c, or it's sometimes also, if it is happens, so after we can discuss a is equal to b is equal to c, or a is equal to b, it's not equal to, so depending on the crystal structure system it can be possible. But the main lattice parameters is a, b, c, that is the intercept point of the atomic in the xyz plane, and the interfacial angle, that is in x axis, y axis, and z axis. Okay, this is the lattice parameter. We can go through this in the later lecture video actually. Okay, now so today's thank you very much for watching me and listening me. Goodbye.